Hello, biology students. I hope you're having a good Thursday morning. And I talked to you a little bit yesterday about going through some notes. I want you to get out your note packet and grab a highlighter back there in the box if you need one, just like we would if I was standing up in front of the classroom. And we're going to take notes. So anything that's in red, highlight. Anything you have a blank for, fill it in. And we're going to go through this and hopefully it makes sense. If you have questions or I go too fast, the nice thing is with the video, you can go back and reverse it and pick up something maybe I went too fast on. And Monday, you can ask me questions about it. So on the screen, you should see, and put your earphones in so you're not bothering your neighbor beside you. On the screen, we're going to talk a little bit about energy and reactions. So how does energy actually change? And we already talked about this over and over and over again. You hear it so much, you probably get tired of hearing it. But energy is never created, nor is it destroyed. It just changes form. And in chemical reactions, bonds are formed and bonds are broken. And when bonds are formed, we're going to store energy and then or absorb it. And when bonds are broken, then that energy is released. So energy changes is one of the most important factors in whether a chemical reaction will even start or if it will occur at all. So that's what we're going to look at today is a little bit about some energy and where does that energy go, and hopefully we'll build a little bit on some of the notes that we've taken already. So hopefully you have what's filled in there and highlighted, what's in red. Not a whole lot to highlight on this first slide, but that's what we're going to talk about. So when chemical reactions that release energy, often they occur on their own spontaneously. Chemical reactions that absorb energy will not occur without a source of energy. So spontaneous, you should know that word just means immediate. It happens really, really fast. And the problem we have in the body, and I'm going to talk about this a little bit more later, one of the biggest problems we have is that some of these reactions just occur so slowly. They'll occur and they'll do it on their own, but our body sometimes needs to speed those things up. If you remember me saying a few days ago that, I even said it yesterday, that 500 quadrillion reactions occur every second. That's basically what we're talking about. So if those reactions occur too slowly, then sometimes we got to help them. And that's where enzymes come in, and we'll talk about them in the future with notes down the road. So that's kind of where we'll start. So are we talking about reactions that absorb energy, or are we talking about reactions that release energy? And we have to do both. You and I and every living thing on this planet, we have to have the ability to release energy. We have to have the ability to absorb energy. And both of those are really important to us having a healthy and functional life as a living thing. Okay. So here's what we come down to. I'm going to show you a cool video here in just a second. Dr. Jim's his name. Hopefully the sound works. I'm doing a retake. I think this is my 5th time through, and I've changed some things. So hopefully it comes through a little better this time. We'll see. If it doesn't, you may have to turn your headphones down a little bit. But you're going to see on the screen a reaction. We talked about this a little bit yesterday. On the left side, we call those reactants. So we have 2 hydrogens and 1 oxygen. Those are our reactants. And they're going to combine and they're going to release 2 H2Os, which sounds pretty simple. And the 2 H2Os is the products. Right side's the product, left side's the reactants. What's kind of cool about this experiment is when that energy gets released, it gets released in the form of heat, which is not a big deal. But when hydrogen gas gets released, then it explodes, and it explodes in light and sound. So we'll talk a little bit more about that in a minute. So I'm going to play the video. Hopefully it comes through on your screen okay, and hopefully the sound's okay, I'm hoping. If sound doesn't come through real well, you at least can see what happens to this reaction that I have on my screen. So here we go.
Experiment that was floating up in the ceiling. So let's take a look at the combustion of hydrogen gas once again. What was the difference? Obviously the second one was a lot louder, but what did I do in the second case? I included in the balloon both the hydrogen and the oxygen that are necessary for reaction. Chemistry is not just about studying reactions, it's about controlling reactions, making them behave the way we want them to behave.
So as you can see from that crazy explosion there, a pretty loud explosion, pretty big flame. That's basically that simple chemical reaction that you see on your screen. It's going to come back up here. Now, on a larger scale, this can be, as Dr. Jim there was talking about, we have to control that. We can't just let that just explode, especially inside the body. So, we have to control reactions like that, and we're going to explain a little bit of how that works. But I do want to share a story about this chemical reaction. Many, many years ago, way before you guys were even born, we had a space shuttle mission, and we had lots of space shuttle missions before that. This one in particular was kind of special, especially to those of us in education, because for the first time we were going to send a teacher into space. So they had a contest. This is when I just started teaching. I was actually teaching Earth and Space Science at that time. And we sent in, all of us teachers around the country sent in experiments that we thought would be kind of neat in space. And then NASA went through and selected ones that they thought was worthy of going into space. And then they selected the teacher that submitted that experiment to be trained as an astronaut, which was landmark. It was a landmark thing because we never had a civilian, a teacher had never been trained to be an astronaut to go on a space shuttle. So everybody was excited about it. So the space was called the Challenger, and they lifted off from Cape Canaveral, and it was going up through the atmosphere like normal, and everybody was watching it because we as teachers were all tuned in. I had my TV on in my classroom, and we were watching the space shuttle go up into the atmosphere, not thinking much of it, and all of a sudden this reaction right here occurred. What happened, and NASA didn't realize this, but hydrogen gas was leaking out the side of the rocket boosters, and when it hit the oxygen from the air, and once it hit the flame of the rocket booster, you can imagine what's going to happen. Way bigger scale than you just watched, and that whole space shuttle, right before all of our eyes, exploded, and nothing left of it, just pieces of it. And we lost all 7 astronauts that day, including the teacher. So it was just an awful day. Very dramatic day because we didn't think anything like that could ever happen to the space shuttle, and it's that chemical reaction right there. So that's why you have to control this reaction, not let it get out of control. And they fixed that problem. They've had no space shuttle disaster since then, but it was really a crazy day. So that's basically a chemical reaction. Okay. The reverse of that reaction, you also can take that reaction and go the other way. It's a reversible reaction, and you can take water and energy, put electrical current through water, and you actually can split it back into hydrogen and oxygen. So there's a lot of talk. I think that was on the video a little bit yesterday with James Corbin when we watched it yesterday, was hydrogen could be our future energy source. It could be the fuel of the future, because if we can find a way to harness that energy and not explode it, it'd be kind of cool that maybe someday instead of putting gas in our car, we can put water in our car and we can run it off of that reaction. And not only would that be kind of nice for a car to go down the road, but it would also release oxygen into the atmosphere as well. So that wouldn't be a bad thing either. But the big thing is, what do we do with the hydrogen that gets released? And that's what they're trying to figure out. And we don't want it just explode. No one wants an explosion occurring in their car. So